Want to build awesome backends easily? Let me introduce you to NestJS. It's a framework that makes backend development fun and simple, especially if you're a fan of TypeScript. So in this video, I will show you everything you need to know to get started, like setting up your first project, understanding the core concepts, and diving into cool features like custom middleware and handling authentication. So here's what we'll cover in this video. So first, we will talk about what NestJS is and why it's such a great choice for backend development. Then, we will walk you through the installation process and create our first project. After that, we will dive into the core building blocks of NestJS like modules, controllers, and services. We'll also go over how dependency injection works and why it's so helpful. I'll show you how to handle routing and how to use middleware in your app. Next, we will talk about request lifecycle and how pipes help you with data validation and transformation. Next, I'll explain how to use guards for authorization and access control to your app. We'll also dive into exception filters to handle errors in a clean and consistent way. You'll learn how to log requests and track performance using Interceptors. Finally, we'll be exploring database integration with TypeORM, Mongoose, and Prisma to store and manage your data. I'll also show you how to manage environment variables and set up authentication using JWT and OAuth2. And by the end of this video, you will have a solid grasp on NestJS and be ready to build your own backend applications. So before we move on, here's a quick information. If you're ready to kickstart your career as a full-stack developer, check out Simplilearn's AI-powered full-stack developer program. This program is perfect for you. Why? Because you won't just learn how to build modern web apps using the MERN stack like React, Node.js, MongoDB, but also tap into AI-powered tools that will supercharge your development process. But that's just the beginning. You'll get hands-on experience by working on over 60 real-world projects, everything from building interactive websites to developing scalable applications. And the best part is, you will earn an official Microsoft certificate to boost your CV and show the world that you are ready to take on a job. Plus, with AI-powered job assistance, you will get tailored resume, mock interviews, and personalized job opportunities to help you land your dream role. Imagine being job ready with everything you need to know to shine. So what are you waiting for? Hurry up and enroll now. You can find the course link below. Let's get started with a quick quiz question. The question is, what programming language is NestJS primarily built with? Your options are JavaScript, TypeScript, Python, or Java. Let me know your answers in the comment section below. So first, let's understand what is NestJS. Now, NestJS is a modern framework designed to help developers to build scalable and maintainable server-side application using Node.js. Now, it is built with TypeScript, which is a superset of JavaScript that adds static types, ensuring better development tools and reducing the chance of errors in your code. But don't worry, if you prefer JavaScript, you can still use NestJS with plain JavaScript. At its core, NestJS wraps around popular libraries like Express or Fastify to handle HTTP requests while offering a cleaner, more structured way of building your application. NestJS organizes everything into modules, controllers, and services to help you manage your code better as your project grows. First one is modules. Now, modules will help you to organize related pieces of functionality together. Next, we've got controllers. Now, controllers handle incoming requests and it returns responses. Then we've got providers or services. Now, this contains business logic such as data manipulation and database interactions. NestJS also makes heavy use of TypeScript's type system, which means that the code is more predictable and safer to use. Now, let's talk about why should you use NestJS in 2026. Now, in coming years, backend development is becoming more complex and developers need frameworks that are scalable, secure, and easy to maintain. NestJS is perfect for meeting these needs. Here's why. First of all, it gives you clear structure and best practices. NestJS gives you a structured and opinionated way to build applications, which means you don't have to make every decision about how to organize your code. From day one, NestJS provides a standard layout that works well for both small and large projects. Then we've got modularity and scalability. Now, as your project grows, NestJS makes it easy to break your app into smaller independent modules like authentication or product management. This approach allows teams to work on different parts of the app without stepping on each other's toes, making the code base easier to scale and maintain. Then we've got dependency injection DI made easy. NestJS uses dependency injection to manage how pieces of your application communicate with each other. This makes your code loosely coupled, meaning that parts of your code are less dependent on each other, making it easier to test and maintain. Let's suppose, for instance, in your application, you can inject services like a user service into controllers without having to manually manage how they are created. Next one is TypeScript benefits. NestJS fully embraces TypeScript, giving you tools like compile time safety. Now, this means fewer errors at runtime and better developer experience with features like auto-completion and in-depth documentation. Next one is out-of-the-box features. Now, NestJS comes with built-in features like validation to make sure incoming data is correct. Next is testing tools, such as Jest integration for unit test. Next is configuration management, which keeps settings for different environments. And don't worry, if you're getting confused by all of these complicated words, I'll be explaining each and everything in the coming later section. Okay, so this means that you don't have to spend time adding these libraries manually. You can focus on building the actual features. Now, let's compare NestJS with some popular frameworks. NestJS isn't the only framework available for building Node.js applications. Let's compare it to other popular options like Express and Koa to understand where it stands. If we talk about the feature, the architecture, then Express is very minimal and unopinionated. And if we talk about Koa, then it's a middleware based. Nest is very opinionated. It has got modules, controllers, and services. And in Express, it has got manual wiring. And in Koa, it has got manual wiring. But in NestJS, it is built in with reflect metadata. Next one is TypeScript support. Now, in Express, it is via definitely typed. In Koa, it is again definitely typed, but it supports first class with decorators. If we talk about CLI tooling, Express supports none, third party. Koa also supports none, but NestJS is built with NestJS CLI. I'll explain you later how it works. Then we've got testing. Express is user configured, Koa is also user configured, and NestJS, it is built in Jest support. Then we've got learning curve. Express is very low, Koa is again low, and NestJS, it is medium due to some Nest specific patterns. Then we've got ecosystem. Express is middleware library, Koa is again middleware library, and NestJS, it is full stack, including GraphQL and microservices. Now, Express is great if you need complete control over your application structure, but it requires you to build everything by yourself, like validation and testing. And if we talk about Koa, then it's slightly more and flexible than Express, but still leaves decisions to the developer. And finally, NestJS gives you everything out of the box like structured code, DI, validation, testing tools, and official integration for WebSockets, GraphQL, microservices, and many more. It's a great choice. If you prefer a framework that helps you follow best practices and builds on TypeScript, then you should definitely go with NestJS. Now it's time to discuss some real-world use cases for NestJS. Might require extra work to implement. Now, here are a few examples. First one is enterprise APIs. Now, when building large-scale APIs with strict boundaries like authentication, product management, NestJS modular structure and D makes it very easy to. Next, we've got microservices. Now, if you're building microservices architecture, Nest can easily integrate with message brokers like RabbitMQ or Kafka to help different services communicate together. Then we've got real-time applications, that is building chat apps or live dashboard. It can be built very simply by using thanks to its built WebSocket gateways. Then now NestJS supports GraphQL and it can help you build code-first GraphQL schemas without a lot of boilerplate code. Now let's dive into setting up your environment and building your first NestJS project. So we'll be going step by step to get your NestJS project up and running. First, we'll begin by installing the CLI, which stands for Command Line Interface, creating a new project and then understanding the folder structure. So let's get started by installing the CLI first. Now, NestJS comes with an official command line tool that makes it easy to generate different parts of your application, like modules, controllers, services, and many more. Now, this tool will help keep everything organized and consistent while you're building your app. So the first thing is to install the NestJS CLI globally. This means that you will be able to use the nest command anywhere on your computer. So let me show you how to do that. First, you just need to search on your computer, command terminal, and or Windows PowerShell from here, and then you just need to enter this command. The command is npm install -g @nestjs/cli, and then we'll just press enter. Now it will take some time to install all the packages, so let us just wait for a few seconds. So as you can see here, it says change 215 packages and 38 packages are looking for funding. Run npm fund for more details. So if you want to check out more details, we'll just type here npm fund. So from here, you can just check out all the details, the packages which has been installed. You can see opencollective.com express, then we've got github.com sponsored, then we've got intrinsic and many things, right? So now that our packages has been installed, now you might be getting confused that what exactly is happening here. Well, the npm install g will tell the npm, which is the node package manager, to install a package globally on your machine. Then the @nestjs CLI, which we used here, is the package that will include all the NestJS commands that you will be using. -g actually means global, so you can use this command anywhere in your terminal. Now that you can see all the packages has been installed, you can now check if everything went well by running this command here. This is nest-help. Just press enter after that. So this will actually show you all the available commands that you can use with the Nest CLI. So you can see all the commands from here: build, info, add, generate, name, classification, the name, the alias, and the description for each function that you will be using here. Now let's start by creating your first project. Now you can see that our CLI has been installed. Let's create your first Nest.js project. So now we'll be running a command to create a new folder with starter NestJS application. The command is nest new my nest app. So I've given this name to my folder. You can actually give any name, whatever you want, and just press enter from here. So as you can see, it says we will scaffold your app in few seconds. Which package manager would you love to use? So you've got plenty of option here, npm yarn. So we'll just go with npm. So just click on that and hit enter from here. Okay, so now I've given a different folder name from here because we had already used the same folder name before. That is why some error had occurred. So now I've given the other folder name and it says which package manager would you love to use, and I've selected npm again, and it's actually creating the packages. Now you can see from here, create my nest app, my nest ASL configurations, packages, readme.md, TS JSON files, controllers, module, service, and so many things. So we'll just wait for a few seconds till it is being installed. Now, this basically creates a new project named as my nest app. I've used because previously I've used app here in a folder of the same name. Now, after running this command, the CLI will ask you if you want to use npm or yarn. You can choose either, but npm is already set by default. It will also ask you, just in case, that if you want to enable strict TypeScript settings, it's good to keep it enabled for better code safety. So now as you can see, it's successfully created project my nest app. Get started with the following commands. So you can just copy paste this command directly from here, or you can just enter this command, which is cd my nest app. So now that your project is created, you need to go to the project directory, right? And for this, we need to enter this command, which is cd my nest app, and just click on enter. So what's happening here is this will change your terminal's current working directory to the my nest app folder. You can start a development server. Let's start the app and see that if it's running or not. So we'll be running this command here to get it started, which is npm run start. And then we'll be also entering this dev from here. By default, it was not there. Just hit on enter. Now this command will run the NestJS development server. This dev part means that it will also enable hot reloading. So whenever you change a file, it will automatically restart the server for you. Now once it's running, you can open your browser and you can go to the server, which is localhost 3000. And you will see a message known as hello world. So let me just go back to the server. Alright, so here as you can see this message, and this is the URL for this, which is localhost 3000, and you'll be seeing this message here, which is hello world. This means that your server is up and it's running. Now to open and edit this structure, you need to open the generated project folder in your code editor. So right now I'm using VS Code, so we'll just go back to our terminal here. And here's how you can do it. You can navigate to the project folder that you created. So we'll just open the terminal again from here, and we'll give the directory here, which is cd my nest. So if you're using VS Code, then you can run this command, which is code that will automatically redirect you to your VS Code. Okay, so it's opening now. Now you can also use any other editor. So right now I'm using VS Code, and it's preferably the best code editor for me. So you can, if you have a VS Code, you can do that. If not, then you can install other code editors here. I would suggest you to go with VS Code itself. Now this will open the entire project folder in your VS Code window. You will be able to see the project structure right here. As you can see, your My Nest app, dist, node modules, the source, test, and everything. So this would be shown here. Now this is basically the project structure, which is what we are discussing here, right? Now this is the default structure that NestJS generates for you. This is My Nest app. This would be the structure. Then you've got controller in TypeScript, app.service.ts, and then you've got the source files from here, test from here, package JSON, and everything. Now make sure that your structure is in the correct way, just like this. So let's break down these files and what it actually means. The first one is the source file. This is the source folder where the core application files are kept. Then you've got this app.controller.ts, and this is where the controller is located. A controller will handle incoming requests like when you hit an API endpoint. Then you've got this app.controller spec.ts, and this is the unit test for the controller. Now you can write tests to make sure that your controller works as expected. Then you've got app.module.ts. This is the root module of your application. It will organize the application by grouping controllers and provider, which is services. Then you've got this app.services.ts, and this is the service where the business logic resides. It handles things like database calls or complex data processing. Then you've got TS. This is the entry point where the application starts. It creates an instance of the app and it begins listening for incoming requests. Then you've got this test source files from here. Now this folder is basically for your end-to-end test. These tests are used to verify that the entire application works as expected. Then you have this package.json file here. This file contains details about your project like its name, version, and the scripts that you can run, such as npm run start. Then you have got this tsconfig.json file. This file configures TypeScript. It tells TypeScript how to compile your code. Then you have this nest CLI JSON file. This is the configuration file for the NestJS CLI, used to set up and run various commands. So you can now open and edit these files inside the source folder, such as app controllers, app services, to start building your application. Now, let's start by understanding the source main.ts code from here. This is actually the bootstrap file. Now, this is the file that starts your NestJS application, and it's called the bootstrap file. And it's where your app is initialized and it begins running. So you can see the code from here, which is import nest factory from NestJS code. Then it's import app module from app.module, async function bootstrap, const app is equals to wait nest factory.create, wait app.listen process, and then last is your bootstrap function. So let me just explain you this code. The first line which you see from here, which is import nest factory from NestJS code. Basically, we are importing the nest factory from NestJS core library. The nest factory is responsible for creating a new instance of the NestJS application. Now, import app module from this app.module, which you see here in the second line. What this does is we are importing the app module, which is the root module of the application. It's just like the central hub where all the other components like the controller, services, and all of these are registered. Then you have this const app is equals to await nest factory, right? So this basically creates the NestJS application using the app module. The app module contains the configuration and setup for the app. And the await keyword here ensures that the app is fully created before moving on to the next step. And which you see here, the next one, await app is equals to listen process.env port 3000. So basically this starts the HTTP server on port 3000, and this is the port your app will listen to for incoming HTTP request. So you remember previously I showed you the message hello world in this particular port, right? So this is basically for showing your messages and all the HTTP requests, whatever you'll be receiving. Now, once the server starts, this line of the URL where the app is running, which should be localhost.3000, which I told you before. Now the second step is understanding the source app.module.ts. So we have this folder here, app.module. This is in TypeScript. So basically, you don't need to actually code this entire thing, because once you run the function, once you create the CLI in the terminal, it will be automatically directed to your code editor, all the codes and everything. Now, if you want to add any special functionality or any special features from here, you can also code manually, but if you just go to the terminal again and just type to create this particular folder here or create this file, it will do it for you. And this is how amazing NestJS is. So let's understand the app.module TypeScript file from here. So this is basically the root module. Now this file is where we define the structure of the application. It ties together different parts of the applications like controllers and services. So you can see the code from here, which is import module from NestJS common, import app controller, app service, and module imports controllers providers. So let me just explain it to you what it actually means. So as you can see from here, this module function, right? Now this is a decorator here in NestJS that marks the class as a module. Now in NestJS, everything is organized into modules which contain different pieces of functionality. Then the imports here, what it does is, this array will contain other modules that the current module depends on. For now, it's empty, but you will add things like database modules or authentication modules here as your app grows. Then you've got these controllers, right? The app controller. So this will tell NestJS to register the app controller, which are basically responsible for handling incoming HTTP requests and returning responses. Then you've got these providers, app service. So what it does, it tells NestJS to register the app service. Services are used to handle the business logic of your application. Example, fetching data, performing calculations. Let's move on to a third step, understanding this app.controller.ts. So this file, let us understand this code. Now, controllers in NestJS are responsible for handling, again, HTTP requests, I've told you many times, and also returning the responses. This is where you define what happens when users visit specific URLs. So you have this code here, import controller get from controller export class app controller. Let me explain it to you what it actually means. You can see this function, right? At controller function. This is a decorator here, and this marks the class as a controller. This is where the logic for handling incoming request goes. You have this constructor, private, read-only app services. What it does is, this is a dependency injection in action. The app controller needs the app service to do the job. So NestJS injects the service into the controller automatically. Then you have this get function from here. This is a decorator which marks the get hello method as the handler for get request to the root, that is your localhost 3000 port. Then you have got this function get hello string, right? Now this method calls the get hello method from the app service to get the message that will be sent as the response. Next step is to understand the source app.service.ts from here, which is app.service, this particular file. Now, services are the business logic of your application, and they handle things like data retrieval, processing, and other operations that don't belong in controllers. So here is the code for this. So let me explain it to you. It says import injectable from NestJS common, injectable decorator is there, export class app service, get hello string, return hello world. So as you can see, this injectable, right? So what it does is, now this decorator marks the class as injectable. This means that all the other parts of the app, like the controllers, can inject this service and it can use its methods. Then you have this get hello from here. Now this is basically a simple method that returns the string, which is hello world. In real application, it could be doing something more complex like querying a database or calling another service. Now it's time to move on to the next step, which is generating more code, modules, controllers, and services. So guys, once you're familiar with the basic structure, you would want to add more functionality, right? Now NestJS makes it easy to generate new modules, controllers, and services with simple commands. Where to run these commands? You can open your terminal again or the command prompt which you're using. Now if you're using VS Code, you can open your terminal directly within the VS Code by pressing Ctrl plus hyphen or using the menu view terminal from here. So we'll just go back to a terminal again from here. Okay, now this was my terminal which we were using. So now we'll be running some commands here. Now once you're inside the project folder, you can run the following commands one by one in the terminal. The first command is nest g module tasks and just click on enter. So you can see here it says create source task.module.ts update. All right. So what it does, it is basically generates a new module known as task. Now modules are used to organize related functionality in your app. For example, the task module that could handle everything related to task management. Then we'll be entering one more command, which is nest g controller tasks and just click on enter. Okay. So again, we have created one more file. It says create update. In the backend, you can see some of the files creating, right? So what it does, it basically generates a new controller known as task. The controller will handle HTTP requests related to task, such as creating, updating, and deleting your task. Then we'll be creating one more function here, which is nest g service tasks. So what this command does, it generates a new service known as task. The service will contain the business logic for managing tasks. Let's say, for example, fetching task from a database or performing calculations. So what basically happens when you run these commands? Well, the CLI creates new files for each of these components and places them in the appropriate folders. So in the backend, you can see all of these happening, right? This one. So it's basically creating your files and you can just direct it directly in your code editor from here. It also updates the module's metadata to include the new controller and service, so everything is automatically wired together. Now with the basic files and understanding in place, you can start building more complex features. So we'll just go back to our code editor again, the VS Code. So we'll just enter this command code dot and just click on enter. So here is the code editor we have created. So from here you can see the project folder, right, which we have created task controller.ts, task module. So let me go back to the terminal once again. So we had created the module task, the controller task. So you can see it here in your VS Code, the module task, and you can also see the controller task from here. So these are the new features which we have created. Now this task module.ts file, this will automatically update to include the task controllers TS and the task service TS. This means that when NestJS creates these files, it automatically connects them together, making the task module more functional. So once you have generated the new module controller service, you can start adding functionality to your task app. So we have this task controller.ts, right? So basically this particular file will define rules to handle HTTP requests like creating, updating, and again deleting task. Then you have this task.service.ts. Now this will write the business logic for managing tasks such as fetching tasks from a database or performing calculations. Then you have this task.module.ts. Now this will ensure that the controller and the service are properly registered with the NestJS app. So after setting up your basic NestJS application, next we will dive into the core building blocks of NestJS: modules, controllers, providers, services. Now these are the three pillars at the heart of every NestJS application. Let's explore what each one does, how they fit together in theory and in practice. So let's start by explaining the modules in NestJS first. Now modules in NestJS are the containers that group related components like controllers, providers, services, and even other modules. Now they provide a way to logically organize your app, making it easier to scale and manage. Now, how can you create a module? Using CLI. You can navigate to your project folder using the terminal if you haven't already. So this is your project directory, right? Now you can create a new module for a feature, for example, cats. Then you can just enter this command, which is nest g module cats, and just click on enter. Okay, so this command will basically generate a cats.module.ts file inside your source cats folder. To just check this code out, you can just enter this command again, code dot. Okay. All right, you can see this folder, right? Cats from here. So just open this and you'll be seeing cats.module.ts. So this is the module, the file which we have created just now. You can just manually open the file cats.module to edit or review. You can also use the CLI to open to your editor, which I showed you just now. So you can see the code for this, which is import module from NestJS, module, export. So basically, if you need to add more features and all, you can just edit in this particular code. So we're just doing some more edits in this code since it's not fully functional working code now. So first we have got this import module from NestJS common, right? Next we'll be importing cats controller from cats controller file. So just type import cats controller, close the bracket, from automatically get this thing, right? This is the VS Code AI feature which we use, which is cats.controller. So just click on accept tab from here. Next, you can import a cat service from again this particular folder. So let us import that. Imports. See, automatically it's coming cat service from this particular folder. So next, we have also imported this. Then you've got this module decorator from here, and you have got this controllers and providers, right? So just click on go and accept for this. One more file we need to enter, which is import. Then you can give your type module for feature. Then you've got this controllers and the providers. It's already there. One more thing is missing, which is the export one. So we'll do it manually. Export. And then in bracket, you have this cat service from here. Now this will make your cat service available to other modules from here. Then at last you've got this, which is export class cats module. Now that our entire thing done, and I've also added comment here, which is this one is used for example TypeORM module, and this export is used to make cat service available for other modules as well. So it would be more clear to you. Now let me just explain you this code. So as you can see this @module here. Now this decorator is used to define a module in NestJS, and this is where you define your module's components. Then you've got the controllers, cats controller. Now these are the controllers related to this module. Then you've got the providers, the services or the providers related to the module. Then we have exports here. Now if you want other modules to use something from this module, like a service, you can add it here. Now the next step is explaining the controllers in NestJS. Now controllers are again responsible, I told you before, for HTTP requests, which is get, post, etc. and responding to clients. So you can generate a new controller using your CLI. Let's go back to our terminal and just type nestg controller. Now this command will create a cats.controller.ts file in your source cats folder. Let's press enter here. You can see this cats.controller.ts, right? So this automatically adds it to the cats module here. Again, we can see this code here for the cats.controller, which is import controller from nest, controller cats and export. So again, we'll have to just code a little bit. I'll show you how to do that. The first step is import controller, and then you can also add get, post, body, param from @nestjs. All right. So let's add a few more functionalities inside. Controller, get, body, param from common. Then we'll be adding one more line, which is import cat service from cats.service. After that, you can create one more, which is create cat DTO from DTO. All right, just click on accept tab from here. Then you have this decorator here, controller cats, and then you can export class cats controller from here. And then we'll be adding a constructor, private read-only cat service. This is correct. Just click on accept from here. Then we'll be adding one more function, which is get. No, this is @get, guys. Next is find all function. After that, you have returned this .cat service, find all. Close the brackets from here. Then you have @get, and then you have this ID here. And then the next step would be, this is correct, which is find one param ID string, return this cat service, find one ID. All right. After that, we'll be creating one more decorator, which is the post one. Then you can create body, create DTO again from here, return this cat service.create, create cat DTO. And at last, we'll just mention this comment. This is for cats, right? And then you have the closing brackets from here. So again, I've added the comments here for your better understanding. Now let me just explain you this code. So you can see the cats.controller from here. So you can see this decorator, right? Controller cats from here. Now this decorator will basically define a controller for routes related to the cats. All the routes defined here will be prefixed with this /cats. Then you have this get decorator. This will basically map the HTTP get method to the method below it. Let's say, for example, we've got this example of get/cats. This will actually call the find all method. Then you've got this post decorator from here. Now this will map the post method to the method below it. For example, post cats will call the create method. So you have the create method, right? Then you've got this find one param ID. Now this decorator is used to extract the root parameters like ID from /cats. Next, we'll understand the provider services in NestJS. So providers handle the business logic of your application, like interacting with a database or processing data. So how to create a service using CLI? Go back to the terminal here. So we'll go back to our terminal and now we'll be generating a new service. And for this, we have to give the command, which is nestg service cats, and just press enter. So this command creates a cats.service.ts file in the source cats folder and automatically adds it to the cats module. So you can see this here, service.ts, right? So you can manually open the file cats.service to review or modify the generated code. By default, this code will be there, import injectable from. You can just edit the code from here, whatever features you want to add. We'll be importing one more function from here, which is import in brackets inject repository. No, we'll be importing create cat DTO. And here in the injectable part, we'll be adding one more function, which is not found exception from NestJS common. Then you have this create cat DTO from this particular file path. And then you have this injectable function decorator here. Then you can export the class cat service. Then you can give private cats is equals to this array. And this thing again will come, which is create cat DTO, constant new cat, this dot cat push new cat, return new cat. And after this, you can give a function which is find all, return this dot cats. Again, one more function which is find one ID number, const cat is equals to this dot cats dot find. Now give a repeat. Now give a condition if not cat is equals to throw new not found exception. And then you can just return this cat from here. This code, whatever I've written here. So we have got this add injectable decorator. Now this will mark the class as a service that can be injected into another of the app, like the controller. Then you've got this create cat, right? The create method. Now this will create a new cat object and it will add it to an in-memory array of the cats. Then you've got this find all. This method returns all the cats in the array. Then you've got find one ID number. This method finds a specific cat by its ID. If it doesn't find the cat, it will throw a not found exception here. And that is why we have inserted this condition here. If not found, then you can throw this particular exception, that not found exception, right? If that particular ID is not found. Now let's understand how you can generate more code, modules, controllers, and services. Once you're familiar with how modules, controllers, and services actually work, you would want to generate more features. NestJS provides an easy way to generate these parts of your application through the CLI. You can just go back to the terminal here, and then you can create, we have already created NestG module cats. Again, you can do that. So guys, with the basic building blocks in place, you can start adding more features to your application. For example, you can integrate a database by adding TypeORM or Mongoose. You can also implement validation with class validator. And then you can also handle authentication and authorization using Passport or JWT. I'll be explaining you later what it actually means. Next, we'll be exploring dependency injection in more detail, and you'll learn how to manage complex dependencies effectively. So now, let's understand how dependency injection works in NestJS. Well, dependency injection in NestJS is the process of passing the required dependencies, which are like services, data, into a class. Now, this will allow you to keep your classes decoupled from each other, meaning that they don't have to worry about how to create or manage the instances of the objects that they need. Now, when your application starts up, Nest builds a container called an IOC container to manage all your providers like services and other classes and their dependencies as well. Now let's understand how dependency injection works step by step. So you have seen these decorators like injectable, right? Now these decorators are used to mark a class as something that can be injected into some other parts of your app like controllers, which I told you before. Now when a class such as a controller declares a dependency in its constructor like a service, Nest will look for the appropriate provider, usually by class name, and it will inject it. The default scope for providers is singleton, meaning one instance of a service will be shared across your application. But you can also set it for creating new instances for each request or whenever the service is injected. So here's an example of how dependency injection will work with cat service in cat's controller. So we have got this code for cat's controller.ts here. So we'll be creating one more file from here. So just click on new file and the file name will be cat's controller and just mention it as new.ts. Alright. So now let me just give a comment here, which is cats.service.ts. Now, the first thing would be importing the injectables from here. So the code is import injectable, not found exception from here. So just injectable from NestJS common. Next we'll be using this decorator, which is injectable. And then we'll be exporting class cat service, private cats is equals to in this. Alright, no, we just don't need this private cats thing. So we'll just go down and just click on this. This is needed, which is to export the class cat service. Now this would be probably, I'm just commenting out here. This is some logic related to cats here we'll be using. And then just give a bracket. And then we have one more function. I'll just comment this. This is for cats.control.ts, alright. Then you can import controller, just the controller, not this get, post and body and all. So just remove this from NestJS common. And then we'll be importing cats service as well from this cats service. And then you have controller cats, prefix cats, export class cats controller, constructor private, read only, cats services. Alright, so we'll be again accepting this is needed. So I'll just comment here that the cats service is automatically injected here. Alright, and then a closing bracket. Yeah, that's it. So let me explain you what's actually happening here. This injectable decorator will mark cat service as a service that can be injected into another parts of the app. And in the cat's controller, the cat service is automatically injected into the constructor. And you don't need to manually create an instance of cat service. Nest will do it for you. Then you've got the singleton scope. Sorry, just remove this. Now, since cat service is injected, Nest will make sure that only one instance of cat service exists throughout the entire application by default. Next is custom providers and factory providers. Now, in some cases, you may want to inject non-class values like constants, API values, or perform some logic before the injection happens. In NestJS, you can define custom providers to handle these cases. Now, here's how you can create and use custom providers and factory-based injections. The first step is by using the use value to inject plain values. You can inject plain values like constants or objects into your service. So again, let me just create one more file from here and I'll just name it as constant.ts. Now this is for config constant.ts and now you can just export const app name is equals to, and then you can mention a bracket here. Now you can give provide app name, use value is cat's application, or you can also give my awesome app or anything, whatever you want to use, and then the semicolon right here. Next, you need to register the provider in the module, right? So for this, I'll be just commenting out again here, app module.ts. And now you need to import module from NestJS. Then we'll be putting this decorator here, module. Then we've got the providers and the app name. Next, you've got this exports and the app name again. And then the closing bracket and then export class app module. Next, we need to inject the value in a service. So again, I'll be giving a comment here, some service.t and then import injectable inject from NestJS. After that, we'll be using this decorator injectable and then export the class some service again from here. Then we'll be using a constructor, inject app name, private app name. In place of app name, you can also use read-only name if you want. And then you can write who am I. Then you can return running in application and this app name. And then, so you can just, so in this way, you can just access the injected value from here. And then you can just close the bracket. So let me tell you what's actually happening here. So we have used the use value, right? Now this will allow you to inject a plain value, in this case, which I've named it my cat's application, or you can also name it my awesome app, into your application. Now in app module, what is happening here in the module 1 is we register the constant app name as a provider. Now in some service, you can see here class some service from here. So we are using the inject function to inject the value of app name into the name property. Next, you can also use class to swap implementations. Now, in some cases, you might want to swap out implementation of a class, for example, for testing or based on some feature flags. Now, this can be done using use class. First step is you need to define an interface and its implementations. So again, I'll be just writing the code here itself. So let me just comment it out. Logger.interface.ts. So first step is to export interface logger. Next, log message string, error message string void, closing brackets, console logger.ts. I'll be just giving this comment out here. Then use this decorator here again, injectable. Then export class console logger implements logger, log message string void, again accept this. Next one is the file logger. So we're using this injectable here, and then export implements logger, log message string, just accept this. And here would be your logic to write log message to this file. Now this constructor thing, this is not needed here. So just remove this. So remove the brackets from here. Now let's see how you can register your provider in your module. Again, I'll be giving this comment, which is app.module.ts. So first you need to import module from this, just accept it again. Import console logger, right? This is not needed. So we'll just go back again, import console logger, comma, one more file, which is the file logger, file logger from NestJS. Okay. Not from NestJS, it's from the dot file thing, okay? This is the ./logger. Then you have this module here, providers. Just accept this. Provide logger, comma. You have use class, file logger, comma. Now this is actually used for swapping to maybe file logger. Okay, so I'm just mentioning it here. Then you have export class app module. Now this is done. Next we'll see how you can inject a provider into a service. So again, I'll be commenting here, any.service.ts, import injectable inject from NestJS. Again, import logger. Then using this decorator here again, export class any service, constructor inject. Then we'll give log message string, this dot logger. So let me tell you what's actually happening here. So when we're using this use class, this allows us to swap one implementation for another. Let's say, for example, if we want to swap the loggers interface implementation from console logger to file logger. And what is happening in app module is we are registering the logger module and we are using the file logger for all the instances that requires logger. Now let's see how you can use factory to run logic at registration time. Now sometimes you might need to execute some logic like creating a connection or async initialization when setting up a provider. Now this is where use factory comes in. The first step is to define the factory logic to create the provider. So we'll be using the same file here to show you the demo. So the first one I'm mentioning as database.provider.ts. And then you need to export database provider, or you can just mention it as maybe database itself. Then you use provide database connection, but in place of database connection, you can also use database. And then you have use factory async, bracket is equals to greater than. And then you have const connection, right? So first, let me just accept this and just make any changes here. So in place of connection, we're not using this connection here. All right. So connection comes later, I think. First, we have to use const opts ops, which is equals to config service get database option. Then you have const connection, return connection. And then we need to inject one thing, inject config service. And you can actually inject any required dependency from here. Just mentioning it here for your ease. So now that we have seen how you can actually provide a database provider TS, next we will see how you can register the provider in the module. Okay, so we have already shown you how to do this, which is this particular code, import module, and then you have to do this app any service.ts, right? Now we're using use factory. Now this will allow you to define factory logic that will run when NestJS sets up the Let's say for example, the use factory function may contain async logic like creating a database connection. The inject array will tell NestJS like what other dependencies like config servers should be provided to the factory function when it runs. So guys, now that you have learned about dependency injection and how to create custom providers and factory-based injections, next we will be exploring routing and middleware. Now this will show you how to define routes, apply middleware globally or on a specific route and extend your HTTP pipelines. The routing defines how your app handles different requests, while middleware lets you modify or inspect those requests before they reach your controllers. The first step is defining routes. NestJS routing is handled through controllers and decorators. You define routes using decorators like add, get, post, and use parameter decorators like param, body to extract data from the incoming request. How to define routes? You can create a new file in source folder named products.controller.ts. So we can just create a new folder from here, products.controller.ts. So here we'll be writing code. Products controller.ts. So let me just comment this out so that it's more readable. Again, you need to import the controller get post. So let me just accept this first and not just get. We are also importing post plus param, comma, query. Then you also have the body from NestJS common. Rest is fine. So we're not using query and body here. So let me just remove this. Okay, so again, I'll be importing this controller get post param query body. All right, I think I can't use this right here. So I'll be using in my previous one as well. So next, when I have imported all of this in my different text file, we'll be using the controller decorator here. And in the bracket, we're mentioning the products and the prefix here are used the products, right? Then we need to export class products controller, constructor private only. So again, I'll just accept this. Product services, right? Now this is done. Now we'll be using the get decorator here again. So let me just mention it here. Click on find all. Again, we'll be using the query one. Just mention query, category string. So we're not using particularly category here. We're using limit. So let me just type limit. And then I'll say limit is equals to remove this. Then you can use we can use one more query. Limit is equals to 20. We're using the operators here. Return this product service, find all limit to get the products from here. Then you have add get ID. Then find one param. Return this product services again to get the products again. And then use a closing bracket. This is not needed. So we did not put one bracket here. So we'll be using that. Now we're using the post decorator. Then create body, this is correct. We are creating a body, create products, create product DTO, and then return this as well for the post products. And then put one more brackets at last. Now here, as you can see, the controller products, right? The one which we used here, the prefix products. Now this decorator will tell NestJS that all the routes defined in this controller will start with the / product path. For example, the find all method will be available at / products and the find one will be available at products ID. Then you've got this get decorator here. Now this defines a get request handler. It maps the route get products. Then we're using post, which defines a post request handler. It maps to the route post products. You could also use param ID to extract the ID from the URL when you access a route like products. And then the query limit used here. And then we're using the query limit, right? Now this will extract the limit query parameter from the request. Example, products limit is 20. Now let's see how you can apply a middleware in NestJS, which allows you to hook into request response pipeline. You can use middleware to handle tasks like logging, authentication, or request validation before the request reaches to the controller. Let's see how you can apply middleware using CLI. So you can define middleware as either a functional middleware or a class-based middleware. I'll show you both the approaches. So let us first create a file again here, and we'll name it as logger.middleware.ts. So this is the functional middleware example which I'm showing you. So give a function. So write a comment here, logger middleware.ts, and then import injectable. Sorry, not this basically. So we'll be using the second one, all right? So just remove the first part. This is not needed. Injectable thing. Import request response next function from express. Then write export function logger middleware request and all. So just click on this. Then we have console.log $request.method. So in place of this, we are using some other function, which is new date to ISO string. Now it comes here the correct code, and then next. And then you can move to the REST middleware. For the route handler, you can just move to the next middleware. Next, now let's see how you can apply this middleware. So we'll be giving this comment .module.ts. Again, we'll be importing all of these things, which is a module, nest module, middleware consumer from this NestJS, and then import logger middleware. Okay, so we are just not importing logger middleware here. Just mention it as logger from, remove this, logger.middleware. Okay, this is the correct one. Then you have import products module, not the cats one. Cats we had created before. Products module from, just remove this, products/products module, and then give this decorator module. Then imports products module. Then export the class app module. Configure consumer, middleware consumer. Then mention this consumer here. .apply logger, .for routes this star to apply for all the routes. And this one is for applying to the logger. Product, these are for the product routes, right? Okay, and give one more bracket here at last. Here the logger, which is the middleware logs the HTTP request method like get or post and the URL path. Then we're using apply logger, right? What it does is it will tell NestJS to apply the logger middleware to incoming request. Then we use this for routes one. Now this limits the middleware to only be applied to routes starting with products. Let's talk about the class-based middleware example, the authentication check. Again, you need to create a new file called auth.middleware.ts. So go to create a new file, auth.middleware.ts. So I've written this code here for the auth.middleware.ts, which is importing injectable nest middleware from NestJS common, and again importing request response next function, injectable exporting the class auth middleware. Now you can also add additional token validation here. You can also, or else you can proceed with the middleware or handler. Next, we'll see how you can apply this middleware to this security.module.ts file. So you can import this particular thing from here. And this is import module nest module, import user controllers module, export consumer URLs. I've written all the code. Now this one is applicable for the auth middleware .apply, and .for routes is applicable for all the routes in the user controllers. Now let me just explain you this code. You can see the class here, auth middleware, right? So this class is based on middleware. It checks if the authorization header is present in the request. If not, it will return a 401 unauthorized response. So as you can see, it says return res.status 401 if it is not applicable, if it's not valid there. Then you've got this, repeat. The apply auth middleware function. This will tell the NestJS to apply the auth middleware to all the routes. And the for routes user controller, this will limit the middleware to the routes inside the user controller. So guys, now that we have learned about routing middleware, next we will be exploring the request lifecycle and pipes, diving deeper into the data transformations and validation during each request. Let me give you a summary of what we have seen right now. First, we have seen about the routing using decorators like get, post, and controller to define HTTP routes and handling requests in a clean, type-safe way. Then we have also seen the middleware functions that run before a request reaches to a route handler. This is useful for tasks like logging or authentication. Then we have seen apply middleware using either functional or class-based middleware in your app with the apply method. Now let's move on and see the request lifecycle and the pipes. Now the request lifecycle defines the steps NestJS takes to handle each incoming request, and the pipe are an important part of the process. They validate and transform data before it reaches the business logic in your controllers. So what exactly are pipes? So pipes in NestJS are classes that will help transform or validate the data before it reaches the controller's business logic. Pipes sit between the incoming request and the handler controller, ensuring the data is correctly formatted and valid. How to use pipe? First, you need to create a pipes. Now, pipes are classes that implement the pipe transform interface and contain transform method to handle the transformation or validation. Let me show you an example here. So, as you can see in your main.ts file from here, so this is the main.ts file, right? Now, you can set up a global validation pipe to automatically validate incoming data using the validation pipe. So, let me just write the code here. So I've given the code here to import the validation pipe from NestJS, importing this nest factory, then importing app module from app.module, sync function bootstrap, const app is equals to await, app.use global pipes. This will automatically validate and strip unknown properties. Now here the app.use global pipe which we are using here, right? Now this applies the validation pipe globally, meaning every incoming request will be validated. And the validation pipe here ensures that any data transfer object DTO annotated with validation decorators like isString or isEmail is validated before the controller handles the request. Now here, as we have mentioned, whitelist is equals to true. This will strip out any properties not defined in the DTO, keeping your data clean. And the forbid non-whitelisted, what it does it will throw an exception if the request contains properties which are not listed in the DTO. Now let's see the built-in versus the custom pipes. Now NestJS provides several built-in pipes for common tasks like validation, transformation, but you can also create your own custom pipe for more complex use cases. So we have built-in pipes. Now NestJS ships with several built-in pipes like validation pipe for validating DTOs and parse-in pipe for converting string parameters to integers. Let me show an example of using parse-int pipe. So let me just comment here. So I've written this code for the parse-in pipe. This is parse-int pipe, okay? Int pipe.ts. All right. So as you can see, I've imported the pipe. Repeat. So as you can see, I've imported the controller get param, import parse-in pipe, controller products, export this, get ID, get by param. Now the ID is guaranteed to be a number here, and then I've returned this dot product service find one ID. I've used param decorator, right? Now this will tell NestJS to automatically convert the ID parameter to an integer. Now if the value can't be converted to a number, NestJS will throw a bad request exception. Now let's talk about custom pipes. Sometimes you need to implement custom transformation or validation logic. You can write your own pipe like this, which is parse positive int pipe. Now this ensures that the incoming parameter is a positive integer. So first you need to create the parse positive int pipe. So first I've written the code here. You need to import injectable pipe transform, export class.parse positive int, and check if is nan parsed value. So here in this condition we're checking if nan parsed value or parsed value is less than equals to 0. Repeat. Or parsed value is less than equals to 0, then you can throw new bad request exception $value. This is, it is not a valid positive integer here, and then you can return parsed value. So now let me show you how you can use custom pipes in controllers. In controllers, how you can use that. Now, this is the code for this. Importing the controller get param again, export class orders controller, get order ID, get order at param, and order ID is guaranteed to be a positive integer here. Previously it was ID is guaranteed to repeat. Previously, it was ID is guaranteed to repeat. Previously, it was ID is guaranteed to be a number here, and this time it should be a positive integer. So here, parse positive int pipe. Now this custom pipe will check if the value is a positive integer. If not, it will throw a bad request exception. Here, the param order ID decorator, what it does is it applies the custom pipe to the order ID parameter in the URL, and it ensures that the order ID is a positive integer before passing it to the controller method. So guys, now that we have covered pipes and their role in data transformation and validation, we will now discuss and dive into guards and authorization. Guards allow us to control access to our routes based on authentication and user roles. Basically, guards are responsible for controlling access to your. They act like bouncers at a club, deciding whether a request should be allowed to proceed or not, based on specific conditions like authentication, user roles, or feature flags. Let me show you how you can implement guards. So basically, again, I told you guards are classes that implement the can activate interface. So basically, guards are classes that implement the can activate interface. They are executed before the request reaches the route handler and are useful for authentication, authorization, and custom logic checks. So let's see how guard works. Well, guards check if a request should proceed based on a custom logic or not. Now, if a guard returns true, the request is allowed to proceed. And if the guard returns false or throws an exception, example, unauthorized exception, the request is then blocked. Guards can be applied globally for all the routes at the controller level or an individual routes using the @useGuards decorator. So let's see how you can create a simple auth guard authentication. So we'll start by creating an authentication guard that checks if a request has a valid authorization token. How to implement the auth guard? Okay. So how can you implement the auth guard? First, you need to create an authguard.ts file in the source folder. So again, we'll just create one more folder, authguard.ts file. And now we'll be just coding here, injectable, can activate, execution context from NestJS. And one more function we'll be using here, which is unauthorized exception. Okay, so just mention this as well. From NestJS common, this is correct. And then you'll be using this decorator, injectable, export class authguard, accept this, can activate context, execution context, boolean. Then you mention const request is equals to const switch to HTTP get request. So what it does is it will access the HTTP request. Then you have const auth header, request headers authorization. This will get the authorization header. Then throw new unauthorized exception, no authorization header provided. I'll explain you. Wait, let me just code this first. Then you have const token. Okay, this is const split. Now if token is not equals to my secret token, then throw new unauthorized exception from here, invalid token. Now optionally what you can do is you can attach user data to the request object here. Then you have request user ID1 name John Doe. You can just mention any name from here. This is the example user data. And then return true. This will allow the request to proceed. And at last give one more bracket. So let me explain you the auth guard can activate function here. This method is the core of the guard. It will check whether the request is allowed to proceed or not. Then you've got this execution context here. This will give access to the request, response, and route metadata. Then you have this auth header dot split, right? Now this extracts the token from the authorization header formatted as bearer token. Then we threw this exception, the unauthorized exception here. Now if the token is missing or if it's invalid, we can throw an exception which prevents the request from continuing. Then we can request the user, we can attach user data to the request object for further use in the route handler. Then you can apply the guard. Now you can apply the auth guard globally at the controller level or in an individual route. Now if you want to apply the auth guard to every route in your app, you can do it globally in the main.ts file as well. So here is the main.ts file. So here is the code for this. First, we need to import Nest Factory, then import app module, import auth guard, async function bootstrap, const app await Nest Factory, app.use global guards, await app.listen, and then last is bootstrap. You can also apply the guard at the controller level. If you only want to apply the auth guard to specific controllers, you can use the @useguards decorator. So let me show you code for this. Now I've written the code here. This is profile controller.ts, importing controller, get useguards, import auth guard, controller profile, useguards auth guard. This will be applied to all the routes in the controller. And then the return request user, this will have the user data attached by the auth. Now you can also apply the guard on the individual routes. You can apply auth guard to specific routes as well. So let me show you a code for this. This is for the sum controller.ts. Import this, import auth guard, controller admin, exporting the class administrator admin controller from here. And this will be only applied to the specific route from here using useguards auth guard, get admin data, return data, admin data. Next, we have role-based access control, RBAC. Now, once the user is authenticated, you might need to check whether they have the right roles or permissions to access certain routes or resources. Role-based access control helps in this scenario. That is how to implement role-based guards. You can create a role guard. Now, this guard will check if the authenticated user has the connected roles or not. Let me show you code for this. Again, just click on new file, roles.guard.ts. And you are just mention roles.guard.ts. Again, you just need to import injectable and everything. Repeat. So you need to import this first. So I have my full code ready now. As you can see, importing injectable, import, and return true if the user has a required role, which will allow the request. And this will get the roles metadata from here. And if you want to check if the user has one of the required roles, you can do it by using const has role required roles dot sum role, which is greater user dot roles. All right. So you can do it in this manner. So here you can repeat. So here you can see I've used this reflector function, right? Now this method will retrieve the roles metadata from the route handler, which is this dot reflector get string. Then we have the has role. Now what has role does is it will check if the user has at least one of the required roles. Then you've got this forbidden exception. Now if the user doesn't have the required roles, it will throw a 403 forbidden exception. Let's see how you can apply role-based guards now. So first, we need to define role-based decorator to set required roles for a route. So I'll be just coding here itself, roles decorator ts. So you can import set metadata from NestJS, then export const role. That's it. Next, you can also use the roles decorator and guard in the controller. So projects controller.ts. And here is the code. First importing, all right, controller, create, return. So as you can see, we have used roles, right? Now roles user admin specifies that a user must have either the user or admin role to access the find all method. Then the roles guard checks if the authenticated user has one of these roles before allowing access. So now that you have understood guards and how to implement authentication and role-based authorization, next we will look into exception filters, which will help you handle and format errors centrally. So in summary, we can say that guards are used to control access to routes based on authentication and role checks. And RBAC, which is role-based access control, allows you to enforce permissions based on user roles. You can also apply guards globally at the controller level or at an individual route. So what exactly are exception fillers? So let's understand what is exception filters now. Now in NestJS, exception filters centralize error handling. Now they will allow you to transform thrown exception into consistent HTTP responses, which is particularly useful when working with the APIs or services. Now this approach lets you manage how errors are logged and displayed, offering full control over how exceptions are handled. So let's see how you can handle errors gracefully. By default, NestJS handles exceptions like HTTP exception, example not found exception, bad request exception, gracefully. It turns a structured HTTP response with a status code, message, and an error details. Now, when a controller or service throws an exception, the error is formatted as this particular code. Okay, so let me just show you from here. So this is how it is formatted. The status code 404, message user 2 not found, error not found. Now if an unexpected error like a runtime error occurs, Nest uses default exception filter that sends a 500 internal server error with a generic message. Now I'll be showing an example of how this actually works. So let's create one more file, users service.ts. So first we need to import injectable not found exception from this. So let me show you the code right here itself. So first we need to import. All right. So you need to create a user.service file, import injectable not found exception, export class user service, private users, ID 1, and you can mention any name from here. Let's suppose I mention John. Then find one ID number, const user, this user finds, and the IDs should be equals to the ID, and the user should be greater than equals to you. Now this will throw a not found exception, and NestJS will automatically return a 404 response if the ID doesn't match basically. So this is how the user service, repeat. So this is how it actually works. Next, let's see how you can create custom filters. So while NestJS provides default error handling, you can also create custom exception filters to handle errors in a more tailored way. This is particularly useful for logging errors, adding custom response format, or even managing non-HTTP exceptions like database and errors. So to create a custom filter, you need to implement the exception filter interface or extend the base exception filter. Here's an example I'll be showing you. First one is the logging. Okay, repeat. Cut that line. Here's an example one. Cut that line. Okay. First example is logging exemption filter. This filter logs every exception and delegates the default behavior for HTTP exceptions. So here is the code for logging exception filter in TypeScript. So first you need to import exception filter, augment shots, logger, import base exception filter. Now using this catch function, this will catch all the exceptions from here. You must have known about the catch and throw exceptions, right? And this is the command and the code which you need to write. Then you need to log the error details from here if exception instance of error. Now this .logger.error on the requested method. Now at last you need to delegate the default behavior. This will return the 500, that bad request. Now the custom filter will logs error details and delegates the exception to Nest default filter for structured HTTP error responses. Now let's talk about the custom response shape. Now after handling errors with logging, we can customize how error responses are shaped for consistent client-side handling. For instance, you might want the error responses to follow this structure. So let me just comment here, structure, insert brackets, mention success, not false, error, status code 404. And again, you can give a message that user 2 not found. So this is how the structure is given. So now that we have covered how to handle exceptions, let's explore interceptors. Interceptors are powerful tools in NestJS that allows you to manipulate requests and responses before or after method execution. They can be used for logging, transforming data, or even measuring performance. Next, we'll dive into how interceptors can modify responses and log important details like the execution time of request. Now, if we talk about what exactly are interceptors, now in NestJS, they are used to execute additional logic before or after a method is executed. They're often used for logging, that is to track request execution times, or log incoming or outgoing data. Also used for transforming responses to modify the response data before sending it to the client. Then it's also used for the performance metrics to measure how long a request takes to process. Interceptors can be used to modify or transform the response returned by a controller. Let's say, for example, if you wrap successful response in a uniform structure, such as success, true, data, original data. So here I'll be showing you how you can implement a basic response wrapper. So I'll just mention interceptors. So here's this basic code. First, you need to import injectable, all of these functions, import map, observable, again, export class response interceptor, and then apply this condition here. Map data is greater than equals to, success is equals to true, data. Now the interceptor wraps every response in a very standardized format. And if we talk about the standardized format, let me show you the format here. Format is success, true. Then you have data. Can set this as original data, and then closing brackets. So now that we have seen how interceptors work, while interceptors can transform responses, we also need to ensure that sensitive information, repeat, We also need to ensure that sensitive information such as passwords is not exposed to the client. Let's see how an interceptor can be used to sanitize the response data by removing sensitive fields. So sometimes you may want to filter out sensitive information like passwords before sending the data to the client, right? So now I'll be showing you an example of a sanitize interceptor. This is sanitize interceptor. So first you need to import injectable nest all of these from here. Then also import the observable port map. And then you can use export class sanitize interceptor return rest. Now in this example, if the data contains a password field, it's removed before being sent to the client. This will help protect sensitive data. Next, we will explore how to serialize and transform data using the class transformer library. Now, this can be useful when you want to return specific fields in the response or modify how data is presented to the client. Now, let's understand what is TypeORM with NestJS. Now, TypeORM is a very popular object relational mapping ORM tool that works with relational databases like PostgreSQL, MySQL, and SQLite. It supports two patterns, active record, where entities themselves manage their own database actions, and also data mapper, where the service manages the database interaction. Now, with the help of NestJS, the NestJS TypeORM package will help you set up TypeORM easily by providing automatic connection management through TypeORM module. So the first one is automatic connection management through TypeORM module. So what you need to do is TypeORM module dot for root. Next one is for module scoped repositories for working with your data models via TypeORM module dot for feature. This is TypeORM module dot for feature. They've got dependency injection for easy access to database repositories. Now let's talk about when to choose TypeORM. Now you can use TypeORM when your data is relational, that is tables with relationships between them, and you want the convenience of decorators like entity and column to define schemas. It's especially helpful if you want to build in features like migrations, lazy loading, and query builders. Let me show you an example setup. TypeORM using installing dependencies first. So now we'll just go back to the terminal here. So in the terminal here, we need to just give this command which is npm install -sjs TypeORM reflect metadata. This will install all the dependencies here. So as you can see, it has added 63 packages and audited 193 packages. Now 66 packages has been done. Now, if you want to see more details, you can just run this command npm fund. Now for PostgreSQL, you need to run this command which is npm install -save pg. Okay, so as you can see again, 14 packages has been added and you can just check the details using this npm fund. Next one is Mongoose MongoDB. Now MongoDB is an object document mapper ODM for repeat. Next one is Mongoose. Now, Mongoose is an object document mapper ODM for MongoDB, a NoSQL database. Now, unlike relational database, MongoDB stores data in flexible schema collections. With the help of NestJS, Mongoose integrates Mongoose to define schemas and models using decorators. You can also manage the MongoDB connection via Mongoose module dot for root. Next, you can also inject Mongoose models into services for querying the database. So when should you choose Mongoose? You can use Mongoose if you are working with NoSQL databases like MongoDB, where the data is more flexible and schemas may vary. It's great for projects that don't need the rigid structure of relational databases. So let me show you how you can set up Mongoose in your system. So just give this command npm install -save @nestjs/mongoose. Just click on enter. So as you can see, all the packages have been installed for this. Now next step would be you can just go to the editor and you can set up the service and the schema for this. Next, we'll be looking at Prisma. Now Prisma is a modern ORM query builder that provides type-safe database queries, making it an excellent choice. Now if you want to write error-free queries with auto-completion, this one is perfect for you. So when should you choose Prisma? Prisma is ideal when you want type safety in your queries and a schema-first approach. It works well for relational databases and offers excellent features like automatic migrations, type inference, and raw query support. So how do you set up this? Again, just go to the terminal here and just give this command. The command is npm install /client. Then one more function is there since it has been installed, that is npm install -d Prisma. So now as you can see, it is installed. Now the question is, which database should you choose? TypeORM is perfect if you're dealing with relational data, SQL, and need powerful ORM features like migrations, relations, and repositories. Mongoose is good for you if you're using a flexible schema-less NoSQL database like MongoDB. Prisma is good for you for a type-safe query builder with modern features and a great developer experience. Next, let's talk about environment variables in simple terms. Now, you must be knowing about what is environment variables. Environment variables are used to separate sensitive information like API keys or database URLs from your code. Now, this will help to keep your app flexible and secure, allowing it to run in different environments, development, staging, production, without changing the code. So why should you use environment variables? First of all, for security. You can store sensitive data like passwords securely outside your code base. Then for portability. The same application can run in different environments with different settings. Next is consistency. The application behavior is controlled by the environment variables, so you don't need to change code for different environments. How it works is you can create .env files and in your project with key value pairs to store configuration settings. Let's talk about JWT strategy now. Now JWT is secure compact token that represents user identity. It's used to authenticate users and verify their identity without storing session data on the server. First of all, it's stateless. The server doesn't need to remember user sessions. Expiration, the tokens automatically expire after a certain time. How it works in NestJS is you need to install the dependencies first. Okay, so you just need to run this command npm install at NestJS /jt passport in JWT at NestJS passport. Now, after you have installed it, you can now configure it, and then you can also create auth module setup where you can import necessary modules and set up JWT strategy in your auth module. So now as you can see, it has been installed in my system. We can also use OAuth2, which allows users to log in via third-party providers like Google or GitHub without creating separate password. Now this uses the authorization code flow where a user grants permission and the app gets tokens to access the user's profile. Again, you need to install the dependencies from here. And the command for this is npm install at NestJS /passport. Again, passport Google -o. Just press enter now. So it has installed all the dependencies from here. So guys, now we have learned about handling environment variables. This will help you keep sensitive settings secure and separate from the code, and also how to set up authentication using JWT and OAuth2 strategies. So with this knowledge, your NestJS app will be secure, flexible, and ready for different environments. Alright, we have now covered a lot in this course, from creating env files to securely storing your environment variables. Not only does this make your app more secure, but it also ensures that your code can run smoothly in any environment, whether it's development, staging, or production. Let me also tell you some quick resources to learn more. First is the NestJS documentation. It's an official docs for in-depth learning on modules, configuration, and much more. Then you have 12-factor app methodology, where you can learn how to build environment variables, help with 12-factor app principles. Then you have NestJS config GitHub repository, where you can explore official repository for more details on configuration handling in NestJS. You also have .env documentation, where you can learn how to use the .env package for managing environment variables. And with this knowledge, you are ready to handle configuration securely in your NestJS app and ensure that your code base is maintainable and adaptable across different environments. Now, before you go, here's a quick advice for you. Keep practicing, play around with these concepts, and keep your app configuration organized. You have got this. And if you found this course helpful, don't forget to give it a thumbs up, subscribe for more, and drop any questions or thoughts in the comment section below. Let's continue learning and building awesome things together. Thank you, and keep learning with Simplilearn.